Recall that services are used to exchange data for a short period where a service client makes a request to a service, the service server gets the request and sends a response back to the service client through the service. In this lesson, you will learn how to write a code that requests the Euclidean distance between 2 points on the tortoise when the desired position is passed. This is an example of an Euclidean distance between 2 points. We have object 1 here and then object 2, and you want to calculate the distance between object 1 and object 2. The formula to calculate this distance is the square root of x2 minus x1, this should be x1 squared, plus y2 minus y1 squared. So that will give you the distance between these 2 points. In our own case, what we're going to do is to launch the turtle sim and get the pose of the turtle. Now, in this case, we are only interested in the position, the x comma y. And then we have a desired location that we want to send our turtle to, although we're not sending the turtle there. But then what we want to calculate is get the pose of the turtle and then input your desired location, or in other words, you make a request to calculate the distance between this point and this point, and then you make a request to the client, to the server, and then you get back a response back to the client. So to do that, you're going to launch your terminal, and we are going to use a particular service which we're going to introspect right now. And to introspect on this service, you just type ROS2 interface show, and then the name of the service is called example interface SRV, just like your message file where you have MSG for service, you have SRV, then SRV followed by add to in. So this is the name of the service we want to introspect. Let's check. So we can see that we have three variables inside the service file. The first one is a 64-bit integer called A. The next is also a 64-bit integer called B. Now the A and B are called requests. So you're making a request with the arguments A and B, and in services you always have a response. So when you make a request, you get a response. So when we make a request with A and B, we get a response of sum, which is also a 64-bit integer. Services are usually in this manner, where you have the response and the request separated by these three hyphens. So you always have three hyphens, which means that these are the request data or the request services, or service file or variables, while this is the response. So when you make a request of A and B, you get a response of sum. Okay, so having noted that, we can then go to our code and then start writing a C++ file to use this service. So to do that, you go to your workspace, which is the turtle, and then you go to the src folder. From there to our package, which is turtle control, and then you can go to the src again, where you have your source code. Now inside this source code, we can then create the file. We're going to call this file Euclidean distance server. So let's create the server first in this lesson, and in the next lesson we're going to create the client file. Okay, so I'm going to say Euclidean distance, too long, but let's just leave it that way, and then server.cpp. Okay, Euclidean distance server cpp. All right, I'm gonna make it an executable. Euclidean right, fine. So what we want to do now is to go back to our workspace, and then we launch VS Code. Yeah, beautiful. Okay, now we're on VS Code, and we are gonna locate what we just created, which is the Euclidean distance server. So for the Euclidean distance server, remember, you always want to import the necessary header files or include necessary header file. The first we're going to include is, as usual, the ROS client library. Without the ROS client library, we can do anything with ROS. So we have to bring in the ROS client library for C++. From there, we move to the next one, which is the TortoSim. We're going to use the TortoSim pose, so I'm going to include the TortoSim. And how this task is going to go is that we get the pose from the Torto, and then we also get the request. So from there, we can then know how to calculate the distance between the current pose and our desired pose. Okay, so I'm just going to call this TortoSim. Okay, TortoSim slash msg slash pose.hpp. Okay, right. Now, the last header file we're going to include is the service file that we want to use. Now, the service file we want to use, if you remember very well, it's under examples, example interfaces. And then under that, we have the SRV. And under the SRV, we have add to ints. Remember, this is following the normal convention that you use to include messages or service files. All right, so now let's move on. We're going to create 4 variables. They are float variables, and these are the variables that's going to handle the position and orientation, the position of the turtle and the desired position that we also want. So I'm just going to make 4 of them. So we call x1, x2, and then y1, y2. So because we want to get the distance between the points in x and y axis. Now let's create a callback function that calls back the pose of the turtle in the TortoSim. So I'm going to call this pose callback. Okay, pose callback. And pose callback is going to take const TortoSim message, TortoSim msg, and then pose, because we want to get a pose, shared pointer. And then we give it a name called turtle pose. You can give it any name, it doesn't have to be turtle pose. So we put top inside. So what we want to do is that whenever you subscribe to the pose, we just want to store it into x1. So when it's going to subscribe to the pose and then store whatever it subscribes to the x1. So pose x, then we have y1, top to pose, and then y. All right, so these are the 2 positions, the x1 and the y1. So it's going to subscribe to the pose of the turtle in x-axis and the pose of the turtle in y-axis, and store them in x1 and y1 respectively. So what we want to do next from there is to calculate the distance. Now this function is going to do that. So it's going to get the distance. Remember, what we are creating right now is the server. Once again, I want you to remember that services, they have the service server and the service client. So remember, you make a request through the client, and then the client connects to the server. If the server is not running, the client will not know where to connect to. So the server must be running for the client to connect to the server and request for a particular service, and then the server is going to return or respond to that request and give the answer back to the service. Okay, so the first thing we're going to do here is to put some stuff inside this parentheses, and what we want to do is to create the request and response variable. So I'm just going to call it const std, and then shared pointer, shared ptr, shared pointer. Now when you use const std shared ptr, the next thing you want to put inside is the type of the request that you want to make. Remember, we want to create a variable right now just to handle the request, and then we have to pass in the type that the request is going to use. So the type, just like we have in the messages, the type is example interfaces, and then srv, and then we have add to ints. Now when we have add to ints, remember, services are divided into response and request. So this one we want to make here is the request, so we're going to add the request, and then we call it request. Call it request. Now you can call it anything, it doesn't have to be request. Then we make another one, it's not going to be const this time. Then it's still the same thing, example interfaces, srv, and then we have add to ints, but this time we want it to be response, and then we're going to call the name of this variable response. Okay, so I can take this back here. Now remember, it's a function, we need to put what should be inside the function. Okay, so these are just the parameters that the function is going to be taking. It's going to be taking request and response, and then the question is, what do we want to do when this function is called? So what we want to do first is to get the new pose or the desired pose that we want our turtle to be. So I'm just going to call that x2 as we've declared above. So x2, but what we want to put inside x2 is going to be our request. Remember, request is just like a variable or object that can access a particular structure, and what is inside that structure is the int 64, and int 64a is the a and b variable inside the structure, and then for the response, what is inside is the sum. Okay, so we're just going to say request, and then what do you want to request? We want to request a. Leave it that way. So we're saying that the user should input, should the service server should get the request of a and then store it into x2, and then we do the same thing for y2. We get the request, store it, but it's gonna be b this time, and then we store it into y2. Okay, so now that we have done that, let's make the logic. Like, what do we really want to do? We want to do request sum. Now this is the request part. We've done the response. Now this is the request. The request part is that we want to put something inside sum, and what we want to put inside sum is the distance, the Euclidean distance between 2 points. And this Euclidean distance between 2 points can be written here as SQ, remember SQRT, and then that's the square root of x2 minus x1, square root of x2 minus x1, and then we still want to square this, So put raised to the power of 2. That's why we have the POW power. So 1 raised to the power of 2 of this. And then we put in parentheses here. Okay. So it's going to do that. And then we add it to the power of this one also. Power of y2 minus y1. Just like we have in that formula. Y2 minus y1. And then we put it to the power of 2. So we're squaring it. Okay, that's fine. I believe is something wrong. Okay, check. Oh, I see now. Yep. Trying to make sure oh yeah, I'm having issues with the the parentheses. Okay, so this is the parentheses for this. Okay, I got it now. Square root of the power. Okay. Yeah, I got it now. All right. So yep. So the next thing is to pass in some information, and the information we want to pass, we can use, remember from the previous lesson, we used cout in as the standard C++ way of printing out to the terminal. But this time around, we can also use the Ross logger way of doing things. So we can put in some information using RCL-CPP underscore info. So it means we want to put in information. There are different things. For instance, we have the RCL RCL-CPP. We have for error. We have for debug. So there's so many things we can do with that. But this time around, we just want to print out some bunch of informations on the screen. And then we're just going to do RCL-CPP info, and then we open parentheses. We have RCL-CPP get logger, and we put in whatever we want to, print out here. RCL-CPP. Yeah, RCL-CPP, comma, and then we say incoming coordinates. Yeah, coordinates. So incoming coordinates, and then we can put in a new line and say percentage. Now I'm going to explain all this. Percentage dot to f comma percentage dot to f, and then we put a space. Then we also put percentage dot to f comma percentage dot to f. All right. Then we pass in. Then we pass in x underscore 1 comma y underscore 1 comma space x underscore 2, comma, y underscore 2. All right. Okay, so there's something wrong here, and that's this guy. Okay, it has been properly formatted. So what we just did here is that we say incoming coordinates, and then when it gets to this point, it goes to a new line. That's the new line character. So it goes to a new line, and then we want to format some bunch of information. So we're saying that it should print out a float number. That's the F here, a float number, and the maximum decimal point should be 2. So it's gonna, that's why we have dot 2. So it's gonna print out something with a 2 decimal places, and then we're in 2 decimal places, do the same thing. So it's gonna print the x-axis, the y-axis, the both of them in the 1 and 2 direction. So it prints in the x1 and then prints the y1, and then we have the x2 and y2. So just this is just like an information for you to see what's actually going on, and then to also realize that the code is working fine. Okay, so we can also, print some bunch of information, and then we just say rclcpp underscore info. So this time we want to show something. rclcpp get logger, then we open parentheses, rclcpp, okay, comma, and then whatever you want to put there, we're just going to say sending back response, sending back response, and then just the way it's going to format it is that it's just going to put in percentage LD, then we have response, and then sum. So it's going to take the sum and give us, for instance, let's say we put in, it's going to get the pose of the turtle and then print it out here. And then this second is going to get a pose of the turtle, print it out here. But this second one is our own desired pose. And then after getting that, from line 20 and 21, so after getting that, then it's going to compute the Euclidean distance, which we call sum. And we're using sum because that is what is inside this place. So you have to use what's inside here. So we call it sum. So it's going to compute the Euclidean distance, and whatever the result is, it's going to put it inside sum. So that value in sum is what we want to print out here. So when the client makes a request, there's going to be a response, and the response is going to send back is sending back response, and then it's going to show us this. But then first, the server, which we are writing right now, must be active. Okay, so what we're going to do now is to start writing the main function, since we have this working. So we go to int main, and then we're passing int argc, those are the arguments, char asterisk argb, and then we put in our code. Remember again, if you do not initialize your node, it's not going to work. Nothing is going to work if it's not initialized. So we always want to do rclcpp init, and then we're passing argc, comma argv. All right. So the next thing we want to do after initializing our node is to create the node. So we're just going to say, we want to create a node name, std shared PTR as SharePoint. No, shared PTR. Then RCLCPP node. We want to call the name of our node node. So we're just going to call the name of our node is equal to RCLCPP node make shared. Now we put the parameter we put here is the name of our node. We're going to call the name of our node Euclidean distance server. So call our node Euclidean distance server, and then we end it there. So we create a subscription, RCL CPP. Remember, we have to subscribe to the pose of the turtle. If we do not subscribe to the pose, we're not going to get anything with the callback we did there. So create a subscription. Then the topic, or sorry, the type of the message our subscriber or subscription is going to use is called TurtleSim MSG, and then pose. Okay, do that, call it a shared pointer. Then we say we can give it any name, pose underscore subscribe. Okay, so pose underscore sub underscore is going to subscribe to the position of the turtle. Then we're going to create another variable, RCLCPP service. So now this is where the service comes in. The question is, what type does our service uses? It uses example interfaces, MSG, and then add to int. MSG add to int. Oh, sorry. Our services uses SRV, not MSG. Then add to int. All right, so we put in the shared pointer. And then the name of our service. So we're just going to call it server since it's a service server. So we're going to call it server. And the next thing is we want to subscribe. We want to make the post sub to subscribe to something. So it's just going to do post sub is equal to. Remember, we use node. In our previous code, because we used object-oriented programming, you see sometimes we use the word this, which I always say that it refers to the node, but this time we already declared our node, and then we said that the node name is called Euclidean distance server. So instead of this, we're just going to use node, then create subscription, and you know, it's always what is the type the subscriber or the subscription is using. It's using TurtleSim MSG pose. Okay, and here comes what you want to do whenever you subscribe. The first thing is, which topic do you want to subscribe to? The topic we want to subscribe to is called Turtle1 slash pose. That's the topic. And then the next argument, or the next argument is the quality of service, which is 10, followed by the callback function. The callback function is what you want to do when the subscription to this topic is made. What we want to do when the subscription to the topic is made is this. What we want to do is called post callback. So whenever you subscribe to this topic, we want you to do the post callback. What is inside the post callback? Get the X and Y position of the turtle and store them inside X1 and Y1 so that we can use them to calculate the Euclidean distance. All right. So what we want to do is pose callback. Okay, now moving on, we move to the server. Remember, we have not really used the server. We only wrote the the callback, if I can use that word, that the server is going to use, like what the server is going to do, but we have not really initiated it. So we say server is equal to the node, then followed by the arrow operator, then create service. Okay, so after creating service, the next question is, what type of service are you using? So we're using example interfaces, then SRV, and add to int. Okay, so that's the type of service we're using, followed by shared pointer. Followed by the argument. So the first thing is, what is the topic you want to create here? Oh, sorry, I said topic, the service rather. So we are going to call the server dist 2 points. So meaning distance between 2 points. So distance between 2 points. Yeah, let's just call it that. So the name of our service is distance 2 point or dist underscore 2 underscore points. That's the name of our service. And what we want to do after we subscribe to this or after we create this service is what is going to be by the side, and that is get distance. Use a reference, get underscore distance. Okay, so this is what we want to do to the service. Okay, now let's just print out some bunch of information. Say RCO, wow, info. Just gonna use the info. Then say RCL CPP get logger. Okay, and then we pass in RCL CPP. Where by the time we run this code, you're gonna see how it works. Ready to get distance. So we're saying ready to get distance between between 2 points. Okay, then put a full stop there. So it's just gonna open up, show us this text that says ready to get distance between 2 points, and then we spin our CLCPP. Remember, spin is what keeps your program running. So what you want to spin is the node. Then you create RCL-CPP shutdown so that someone you can terminate the program with Control C. RCL-CPP shutdown. Okay, that is all. That is all. Now there's an error here because our pose is pose underscore, not just pose. And then there is another error. So where's this error coming from? We have another error that says RCL-CPP incoming coordinates to F to F. Okay, everything looks fine. X1, Y1. Okay, and then we have, okay, let me just put space since to make things clearer. Yeah, I think everything is fine. What is the error? Yeah, RCLCPP, RCLCPP get logger, RCLCPP info. Okay, I believe everything is fine. I'm not sure why it's showing error. Oh, oh, oh. This is response, not request. Response. Okay. So it's the response that is using some, not the request. Okay, then we can have response here. Response. Let's see. Yeah. So these are this is the request, the A and B, and then the response is some. All right. Believe everything is fine. Now the next thing we want to do now, if there's any error at all, we're gonna see that from our CMake list. When we build our code, it's gonna show us if there's any error. So what we do now is go to the CMake list where we define some stuffs about the new program we just created. So from the CMake list, we are gonna add the new Turtle, the new services we just created, or the new services that we're using in ROS. That's called find underscore package. So the package we want to find now is the examples underscore interfaces. That's the package responsible for the new service file we're using. Sample underscore interfaces, and we're gonna put the required. Okay, after doing that, we need to put our executable. Just gonna copy this. Yeah, we need to add the executable. In this case, the executable, the SRC is under the executable is under SRC, and the name of the file is Euclidean underscore distance underscore server. Euclidean distance server, and we can just copy this and then put it here. So it's always good to have the same name so that you don't conflict with other programs. So we're just gonna put the same thing here. And then our package depends on RCL CPP. And then it also depends on TotalSim. Yeah, it depends on TotalSim. And it also depends on example interfaces. So instead of total control, we have TotalSim. And then we have example underscore interfaces. So it depends on those three packages, the RCL CPP, the TotalSim, and the example interfaces. Remember, as I said the other time, they are usually what you have on your header files here. Okay, let's go back. Then we add in the target. Now we need to add in the target here and then paste it. Okay, that's interesting. So we are done with the CMake list. The next thing now is to go to the package.xml file. So from the package.xml file, we need to add the example underscore interfaces dependencies. So we need to add it here as our dependence. Example depend. I'm just gonna CV and then example underscore interfaces. Yeah. So now we have the package XML, the CMake list set up. The next thing is to go run the code. Not too sure why there's some kind of errors, but I'm just gonna inspect again. We have the power. Yeah. We also have the power. Yeah. And then we have the square root. Okay, I think that's fine. But anyways, we're gonna know if there's any error later. So, okay, fine. So now let's build our code. So I'm just gonna do Calcon build. If there is error, Calcon is gonna tell us. Okay, yeah, there are a bunch of errors. And let's see. It says failed total control by not providing find example interfaces. CMake is provided. CMake did not find one. Oh, make. Oh, examples. That's the problem. Examples. I said examples instead of example. Yeah, you can see that Calcon is so powerful, and then it's gonna fish out where the error is. So let's try it again. Okay, it failed again. So what are we getting wrong this time? Examples again. Where is that? Examples interfaces. Yeah, we use examples here again. So that's why. Always remember to source. Always remember to save your file before running Calcon build. Okay, it's trying to build again. And hopefully everything works fine this time. Yeah, we now have another error coming from our code. No pointer. Wow. This is a bunch of error. Yeah, it's still throwing the error from this side. And yep. Still throwing the error from that side. And what we're gonna do is fish out what is wrong. Where is the error coming from? Why are we? Oh, I get the error. Did I get it? I don't think so. No. Oh, I get the error. The error is coming from here. It's future that we used instead of PTR. It's a shared point, and that's why it's having problem with response. Oh, everything now solved. Okay, let's go back. You can see it's not a problem. It's not really a problem when you have such kind of errors. What matters is just trying to fish out where the error is and then correcting it. Yeah, everything is fine now. It's working perfect. So we now need to source our workspace. Remember to always source, set up the bash. Voila. So let us run our node to see if it's working. Let's run. And then it's under total control. And then we call it Euclidean distance server. Yeah. Nice. Our code is running and it's telling us already ready to get distance between 2 points. Now the server is working perfectly. Now I'm going to put this on top and then drag it somewhere here so that we can see the root code. So let's explain the code again. So we have the float, which takes the x1, x2, y1, y2 parameters, variables. And then we have the callback function that always gets the pose of the turtle. Now, we haven't run the turtle yet, so this server won't really work fine because we're not really running the turtle. So what it's just going to do is it's going to assign a default value of 0 since it's not getting anything from the topics. So it's just going to assign a default value of 0. But then the code is still working. So we're going to test it in the next lesson. But for now, it's working. So it's going to get the pose in X and Y and then store it in X1, Y1. and then it's going to get the distance also. To get the distance, we need to pass two parameters inside the get distance function, and the two parameters are the request and response. Remember, it doesn't have to be request and response. You can give it any name. What matters is the type that they use. So they must use this type. So it must use this type, the example interfaces SRV add2int. So the type must match the type of the header file that you have included here. Okay, and the same goes with the response. The only difference is that it's going to be a request and the other one is going to be a response. So when you have your response and request, then you can access the request. Remember, the request are these files here, if we can still access them. Yeah, so we have the A and B variables. So we can always say request and then use the arrow operator to access A and the arrow operator to access B, and then we store the values in x2 and y2 respectively. So these are the desired positions that we want, while these ones here are the position of the turtle. So these are the positions of the turtle, but this is the desired position that we want. So when we know the desired position and the position of the turtle, they are just 2 points on the turtle seam. Then we can compute the Euclidean distance, which I call sum, because the response we're going to get is called sum. So it must correspond, it must match. Okay, so then it calculates the square root and then the power of x2 minus x1 squared, and then y2 minus y2 squared, and then it takes the square root and whatever it is, it stores it inside sum, and it's going to impute output to us when it gets a request from the server. It's going to impute incoming coordinates, like whatever we put inside, which we're going to do in the next lesson. So it's going to show us incoming coordinates. It shows us the previous value, that's this one here, getting from the post, and then it also shows us the new one we just put inside. It calculates the sum. When it calculates the sum, it shows us sending back response, and then it tells us the response. If it's 5, 2, 3, 4, whatever, 11, it's going to do that. But our code is not done without the main function. So the main function, the first thing is you want to initialize ROS, and then when you initialize ROS, you want to put in your make your node class. So when you create a node, you tell it the node name. So for instance, I can go back to this place, split horizontally, and then I'm going to source my workspace again, and then call it install setup.bash. So I'm going to source. Now that I've sourced, let us see the topics. ROS topic list. Okay. Now it's not showing anything. Why? Because, oh, sorry, it's a node, not ROS topic. ROS2 node, and then we want to list the nodes. So you can see the node running now. We have the Euclidean distance server. So that's the node. Then after creating the node, we need to create the publisher variable. So this publisher, the subscriber rather, and the way you create subscriber, you put RCL CPP subscription, and then the type of the message your subscriber is using, and then the name of the subscriber. So post_sub is a subscriber. So then it can access the node, create subscription, the type you're using, the topic to subscribe to. So when you do the topic to subscribe to, then the QoS, and after the QoS, the callback function. The callback function is what you want to do when it subscribes to Turtle1 post topic. So what we want to do is just run this code here. Okay, after doing that, then we create for the server. The server follows similar syntax. So node, create service, the type of the service, the type being used, and then the name of the service you want to do, and then the get distance is what you want to do when this service is running. Okay, so what we want to do is the get distance. So we can also introspect on that. So I'm just going to do ROS2 service and then list. Let's see, is it really working? Yeah, you can see dist to point. So that's the server, which is called, where is it again? So it's called dist to point. So it means that our service server is running